All right, I'm going to go ahead and get started. As you can see, this talk is about taking your Python to the cloud. I think historically, there's been a bit of a feeling that Python was mostly a backend language or a scripting language. Certainly with things like the Django and Flask, that's changed. But I do feel like a lot of people are intimidated in trying to make that move all the way to the cloud, even when using those frameworks. So the idea here is to show you how easy it can be to both take your Python code and deploy it to the cloud, but also, once it's there, to make use of CI, CD, and some of the other cool technologies that are out there. So quick show of hands. How many people use Python at least weekly at work? All right. Of those few people, how many of you actually continue to deploy that Python to production? All right. So by the end of this, hopefully everyone will at least know how to do it, even if they can't do it at their job. So when you're starting with something like this, there's lots of choices. There's frameworks. You've got Django, you've got Flask. You can roll your own. On the front-end side, you can use Angular, Ember, Vue. Lots of choices. Same thing with cloud. Heroku, Google App Engine, AWS, Cloud Foundry. You name it, there's lots of options. And it's easy to get overwhelmed. What I've found is it's good to just pick what makes sense to you, what seems to feel natural, and try it out. Make sure that you're using that framework natively. Don't try to fit it into your understanding of how things should work, but try to follow the examples that are out there. Certainly, if you're a fan of Python, there's ways to be kind of idiomatic Python. The same things for most of these frameworks. So I'm just telling you these are the right choices. It's just a joke. Lots of good choices. Feel free to use anything you like. I like Flask and React. Flask is pretty lightweight and simple. Allows me to do the routing that I like to do. And then React, very similar on the front-end side. It's primarily a Vue library, but it's got a really nice ecosystem and makes a lot of things very easy to get started with. Getting started, we've got an extensive amount of prereqs that we need to install, and then I like to start with a failing test. So write a test for something you want to work. The test should fail up front. The reason you want to do this is a little bit counterintuitive, but basically, if the test passes the first time, you don't actually know if your code's doing anything. Maybe the test always passes. So make the test fail the first time, and then try again. So let's see if this actually works. All right. So as I was mentioning, we're going to install our prereqs, pip install Flask. Extremely complicated. You might need to take some notes. And then after that, I'm opening a test. So importing unit test so I can run my tests. Importing my app. So this is the tricky part. There is no app, so this test will fail. Just setting up a little bit of boilerplate just to have a test class. And again, there's lots of ways to do this. This is the way I like to do it. Got a couple of different classes. So setup. Ideally here you do the things you need to do for each of your tests. For this particular test, there's not a whole lot to it, so it's going to be pretty basic. I'm just going to have the test, client setup, and then I'll actually make use of that later on. And then jumping into the next thing. My actual test. This is a very complicated test. I'm making sure that the index route returns. So this is a nice one to have in your test suite. Basically, this is, hey, my app actually launches. I didn't horribly break it with any of my dependency changes or anything like that. So with Flask, well, I'll show you in a second, but with Flask, you can have that index route set up very quickly. And so I'm just going to assert that the response from getting the index route gives me a 200. So very basic test. And then my second test, I'll show you in just a moment after I get through the rest of this. So I'm trying something new here. This is a TTY play. It records your keystrokes and then lets you see it. The idea is I can't do two things at once. So if I'm typing, I'm not talking. Unfortunately, I think I might have typed a little bit too slowly, so you have to bear with me just a little bit. But we go into our app here. This will be relatively simple. If you've seen Flask before, this should be familiar. I'm going to import Flask the correct way. And set up my app. And by the way, feel free to interrupt with questions at any point. One of the nice things about having my typing already done is I can have a conversation while we're doing it. Yeah. Yeah. So that's our, yeah, we're going to get to that in just a minute. Yeah. So we set up our index route. Yeah, so Worker is actually what we're going to use for CI. It's a very cool software as a service, completely free for public projects on GitHub, so highly recommend you check it out. So I'm just going to return nothing, an empty string. Setting up a port, this is really planning for later. When we get to the cloud, you generally don't want to have a hard-coded port, so I took it out. But the only other thing here is just the normal Python boilerplate to make main run. And then finally actually running our app. All right, so as I mentioned, run that first test. I cheated. This was actually a passing test. We'll go back into the test, and we'll write our initial failing test. So as with everyone else, I like to start with hello world. So it's just going to be a greeting. And exact same pattern as before. And you can see how you can kind of just build on this to do more complex things. So I could validate any sort of response that I wanted from there. So app.get hola, and then I'm going to make sure that it returns back. You do have to have a leading backslash there. And then I'm going to make sure it returns back with hello world. Is everybody vaguely familiar with kind of the testing framework and kind of assertions in general? Just in case. So assert equal, I'm saying the result of self.app.get should have a status code that's 200. I'm doing the same thing on the next line. The data that's responded from that getting of hola should be hello world. And we'll drop back into. And as you can see, that route doesn't exist, so it gives me back a 404. So we got a failed test. Now we'll jump back into our actual code. We'll add that route. And then because this is going slow, I'm going to skip ahead a little bit. So we've got our basics of our Python set up, right? And this is the part that hopefully everybody here is very familiar with. Flask is straightforward. You write a couple routes, you go from there. You could imagine that you could write some more complicated code there, right? So you might have some business logic that does some data mining, some machine learning. Could be anything. But it's something that you wanted to write in Python. You've got your backend set up. From there, though, potentially, the JavaScript side of this may be somewhat intimidating. One of the really nice libraries that's out there right now, or I guess CLIs, is Create React App. So this is from the Facebook team, and it basically does all the hard work of setting up Webpack, NPM, all the dependencies you need to have a nice React app, and they continue to update it so you don't have to maintain any of that. What I'm going to show you here is just how you can set up a nice hello world, if I can go back to my slide. All right. And then as you can see, that finished up. We ran the test passed, and you can actually curl, and it gives you back a 200 and says. So we're going to do the exact same thing. Oops. On the so a little bit of upfront setup on Flask, we have to add a static path. There's a couple different ways to do this. For using create React app, I like to do it the way I'm going to show you. But basically, I'm going to point to a subdirectory. So in this case, it's javascript/build. The reason I do that is that's kind of natively where create React app will place its built files. And it's just an easy way for me not to have to mess with the framework. And the exact same thing with the static. That static folder is what create React app uses. Lots of ways to configure this. That's how I've chosen to do it. The one other thing you might want to think about, rather than having your static files within your app the way I've done it here, you could potentially publish those to a CDN. And then instead of render template there, you'd use URL4 and point that to the CDN location. Depends on what you're doing. For something like this, it's kind of cool to have everything all in one. You can have your development environment spin it up very quickly, and it works the exact same way in production. So this is create React app. The one step I skipped was npm install -g create React app. Well, actually, I didn't skip it. Cool. And this is all you have to do to get create React app on your system. I am assuming you have npm installed. If not, brew install node and then npm install. But once you've done that, you name your app. If this is going to be a JavaScript app, you'd want to use a name that reflected what you were doing. Because I'm never going to have this stand alone, I'm just naming it JS, so it creates the correct folder structure to begin with. But you could call it something else and rename or point to the folder that you wanted to within your Flask app. I'm going to skip ahead just a little bit here because, well, we'll keep talking. So what this is doing right now, Yarn is installing. Yarn actually was in the keynote mentioned earlier. It's a very nice package manager produced also by Facebook. It's installing all the dependencies required for Create React app to work. In just a second, it's going to go through a ton of dependencies. So these are all the things you might have to install yourself if you wanted to have a similarly function app. So we've got linters, we've got Babel, we've got WG fetch, any number of other things that are kind of coming in there. And it's all kind of just built for you. You don't have to worry about dependency conflicts or any of those other things. It does have some really nice instructions. We're going to ignore them for the purpose of this, but it's got a test runner. You can eject out into having your own scripts. So package.json, there's almost nothing in here. It's pretty magical if you've seen the big projects. But just a few scripts, start, test, build. So we're going to run test. Runs through all your test cases. And in this case, they all pass because there's really nothing there. From there, let's switch to the other side. We're going to go into app.js. So this is out of the box. I haven't done anything yet. We're going to do just one tiny thing here. We want to add an API call back to our Flask app. And you're going to see this is pretty straightforward and simple, and something that hopefully you could do on your own if you just wanted to throw something together. The idea here is not to become JavaScript experts. It's to do just enough JavaScript so that you can have a professional-looking app, but make use of all the cool things you've done in Flask or Python or anything else that you wanted to have as a backend. So I'm adding constructor. The only reason for this is I want to have a default state set up so that my app doesn't blow up in the cases where the API is not available. So I'm setting this.state to an array of empty images, or empty images array. And then I'm going to add an API call right after this. So one of the things with the React that's kind of cool is it has some built-in functions. So component didn't bounce is one of the more important ones. Basically what this is saying is the React component that you're dealing with has loaded on the page. And this allows you to do things like call API, so that as soon as the component's loading, it calls the API, and then you can have that kind of naturally work. In the absence of that, you'd have to do some logic to notice the page loaded and all that good stuff. So in this case, I'm going to just do a fetch of Ola. And you can see I imported the fetch library up at the top. And then I'm going to take that response and display it on the screen. I'm going to skip through the rest of my typos here, but basically response, and that response will come back to the call to API. And then in the piece that's cut off right down here, there's a place where it just displays the text that was returned. So localhost 5000, and then it just says hello world, because that's our response to Ola with the existing boilerplate on the top. So that's awesome, but it doesn't really do anything that cool. So let's imagine that we had a gallery of images that we wanted to display. Since this is a Python conference, we obviously want to show Pythons. So I've added just a little bit more in here. First thing up at the top is just grabbing some environment variables so I can do a Google custom search. After that, I've added an API route that pulls in a custom search, which is not really that important for the purpose of this. It's just having something that works. But you can imagine this could be any business logic or API that you wanted to use. I'm printing out that JSON response to the console just so I can see it, and then using JSONify from the Flask to return that. One other piece that I wanted to call out, and I mentioned, I haven't got there yet, is when we deploy to the cloud, you don't really want to hard code a port because typically the cloud provider will want to select that for you. So I'm grabbing the port environment variable and using that, and if it doesn't exist, I'll use 5,000 still. And that's pretty much it. So imagine, if you will, again, huge business logic behind the scenes. We've created our API. And we've all got all that running. On the React side, similar small changes. So I've added a slider library, and this is just first Google search for gallery. Added that in. I've created that slider component, and basically all I'm doing is passing in the images I got from JSON, that JSON response, and creating a slider within there. And then you can see at the bottom, and I'll switch to the next slide, our API call has gotten slightly more complicated. So response.json, and then when that comes back, taking those items, running through a map, and just grabbing out the links because I don't care anything else about the Google response, and then still setting that state to the images. In the syntax here, just if you do images within the brackets, it names both the key and the value. So the images key has the value of whatever was in images. It's a nice ES6 syntax. And then finally down here, I'm just displaying that slider that I showed you a moment ago. So relatively simple, not a ton of JavaScript you'd have to know there. And then this is what that looks like locally. So we've got still our same thing. We did change the title just to kind of fit with our theme. And then we've got our slider with dots that you can click on to go across. So that's great. We've got an app. It works locally. I don't have any automation, and there's no real great way to share this with the world because it's running locally. So kind of the next step is really setting up a little bit of homework. So this is actually covered in the keynote, but you can set up a requirements.txt file, and this allows a number of different systems to know, I need to install Flask, and in this case, the Google API client. Beyond that, back to our worker.yaml. So Worker is a cloud-based system. It's free for public GitHub projects. If you need CI, it's worth checking out. But the thing I really like about it, beyond being free, is it lets you keep your configuration with your code. If any of you have run Jenkins instances, you know how painful that can be, where you have to manually set them up. You're doing all that configuration within the tool, and then if the box goes down, you lose it. So with Worker, you set up all the config locally, and it stays with your code. So in this case, I want to use a box that's got Python on it. That's just basically a Docker image that has Python. My build steps are pretty simple. I'm using the virtual environment. I'm running a test on my code, so I'm just doing Python app test. And then I'd have a little bit of troubleshooting stuff here, just tossing out the pip and the Python version. And then there's a built-in step that runs that requirements.txt file I just showed you and installs all my dependencies. Down below, you can see the JavaScript side. I'm using a box that has Node on it, installing everything I need, and then building my bundle. One important thing here, if you ever do a pipeline like this, make sure you notice the CWD there. That changes the working directory so that it has the package.json and everything else you need. Just kind of like a gotcha that could catch you there. And then finally, moving down the file, I'm just running npm build, so that creates that JavaScript bundle that the Python or the Flask references. And then deployment steps. So this is another plugin off GitHub, tossing in some of my credentials, naming my app, and then a very basic smoke test script. I just curl against my URL and make sure that hi returns hola mundo. So I'm not sure how well you can see this, but basically at this point, you'd go to the worker UI, you'd say, yep, new project, it connects to GitHub, and then it just works, which is something really magical if you've, again, set up complex CI systems. You can see here are the steps that run immediately when I push a commit. You can actually see test Python code failed that time. That's because you have to have the requirements.txt file. Without that, your program's not going to run. And then you can see the pipeline I've created here. And this is something that's relatively new and really cool. So I've got my initial build, which just runs npm test, Python test. Then I build my JSON bundle. And then at the end, I deploy. So we've got automated both testing and deployment in about 30 seconds with a single file. Now the cloud portion gets incredibly complicated. So there's a solid 3 files you have to do to push this to Pivotal Cloud Foundry. So we've got a manifest, and I just name my app again. I tell them I'm a Python app. This is actually semi-optional, but I like to explicitly declare things. And then we've got our command to run the app, in this case, app.py. Still got the requirements.txt file we talked about before, and then I'm defining my runtime explicitly, again, so 2713. And then CF push. I'm going to show you exactly what this looks like. So this is basically 2 commands. One is the login. And CF login is just another CLI tool. Basically, brew install, I think it's Cloud Foundry login or Cloud Foundry CLI. I pick the location I want to deploy to, and then I press CF push from within my application directory, and that's it. It pushes the app. It uploads the whole thing, grabs the build pack, does all of my dependencies, and then the app runs. And that's all you have to do. App's on the cloud. Once you're on the cloud, you get all the kind of magical kind of cloud native type features. In this case, I only have a single instance because it's a pretty simple app. But I could easily, with either click a button or a CLI tool, have 5 instances so that everybody could see the wonderful Python images I have there. Up the memory, up the disk limit. It's all kind of up to you depending on what your app does. There's auto scaling, so if I had a lot of traffic, I could automatically scale up. And you can see kind of the logs of system events over here. Not a ton going on there. And then this is another cool piece that's kind of new. You can see the number of crashes, requests, all that good stuff, and then the time for those requests. So this is all out-of-the-box functionality. I didn't do anything special. I'm logging to system.out, and it all just kind of shows up there for you. So hopefully you're seeing a little bit of the power of just like making use of the framework. Because you could spend a lot of time setting up this stuff internally, you know, Kibana, logs, all kinds of Logstash, all that kind of good stuff, but it just works. I didn't do anything. So successful deploy. I now have a web accessible address. It's deployed out there and running. And I think that was, what, 4 files, maybe 5 minutes? Sorry, before I jump into my ad. Any questions or any concerns, thoughts, ideas? Yeah, go ahead. Yeah. Yeah, so Worker supports pretty much anything. I think it's basically Docker images, so anything you can put into a Docker container, you can use for Worker. I think natively the ones that they have kind of pre-built files for, Python, Golang, Java, JavaScript. I'm probably missing 1 or 2, but anything you can think of. You might have to do more work if you're using something that's not one of those common languages, but it works. And it's worker.com, so easy to remember. Yeah. Uh-huh. Yeah. Sorry about that. Right. Right. Yeah, I think a lot of that depends on your requirements. So if you have something you need to run in-house because of legal reasons or something like that, then Concourse, GoCD is a great choice. But certainly if you have the ability to use the cloud and you don't have incredibly complex deployment pipelines, Worker's very easy and a lot of fun. If you move too far beyond kind of its sweet spot, then it may make it more difficult, and something like Concourse or GoCD might be the right answer. All right. Any other questions? All right. So just want to do a quick plug for my employer. So I work at ThoughtWorks, 34 offices, 12 countries. We actually recently opened an office in Barcelona. If anybody's interested, they are hiring. We do a lot of cool things. with both software development as well as organizational transformation. So if those are things that interest you, certainly get in touch. We have kind of 3 pillars associated with that. So obviously we do need to run a sustainable business so that we can continue to employ people. We want to make sure that we're championing software excellence. So nobody wants to work on things that are either backwards or broken, so we try to help everyone along. And then finally, advocating for social and economic justice. So it's great that we're making money and doing cool tech, but it's nice to give back and also help people. A couple of quick references. Flask book by Miguel Greenberg is amazing. Lots of good information out there for free. On the Cloud Foundry side, Ian Houston has done some really nice things. A lot of data science and kind of connections to databases, but it works with Python and Cloud Foundry. And then Create React App, as I mentioned, by Facebook, really, really helpful. And if you're looking to do some JavaScript, it's a lot of fun. And that's it. Thank you very much for coming. I hope you learned something. All right. Oh, thanks. I appreciate it. Yeah. Sure.